The Kansas Technical Retraining Among Industry Targeted Networks, or KanTRAIN, grant project of $11,997,957 is 100% funded through the U.S. Department of Labor's Trade Adjustment Assistance Community College and Career Training Program. The purpose of KanTRAIN is to meet employer demands for skilled workers in high-wage, high-skilled jobs, such as those in advanced manufacturing, by building partnerships with local workforce development boards, business and industry, and our KanTRAIN partners, Garden City Community College, Flint Hills Technical College, Washburn Tech, and Washburn University. The programs that are a part of KanTRAIN are Climate and Energy Control, Industrial Automation, Robotics, Machining, Welding, Aerospace Manufacturing, and Aerospace Coatings and Paint. At WATC, our focus is on incorporating automation processes and equipment into our already established manufacturing programs. In addition to the new equipment, renovated lab space, and redesigned curriculum, KanTRAIN staff members are an additional resource to students by providing assistance in job placement activities like resume building and reviewing, mock interviews, and seeking out employment opportunities for WATC graduates. Manufacturers will significantly accelerate their use of robots in U.S. factories over the next decade as they become cheaper and perform more tasks. The development is expected to dramatically boost productivity and slow the long-standing migration of factories across the globe. Robotics is the study of the design, construction, and operation of robots. Robot design and construction are complex fields, often requiring many years of education. The exciting news is, as robots continue to advance, the operation of them is becoming easier and more user-friendly. The Robotics Industries Association defines a robot as a reprogrammable, multifunctional manipulator designed to move materials, parts, tools, or specialized devices through various programmed motions for the performance of a variety of tasks. Robots have many roles in today's manufacturing environment: assembly, buffing and polishing, cutting, deburring, installing fasteners, material transfer, packaging, painting, and welding. There are several methods of classification for robots. These classifications include articulated, Cartesian, mobile, SCARA, parallel, or delta. Articulated robots are the most flexible and are able to perform the widest variety of tasks. Robots are made up of sections called links. These links are connected to each other by joints. The joints allow movement of the links. Together, the links and joints are called the manipulator. It takes more than just the manipulator in order for the robot to perform tasks. The manipulator is given its instructions from the controller. The controller is a computer that sends instructions to the electrical motors, causing the manipulator to move. The controller also stores the program needed for the robot to operate. The controller can be programmed from a PC or through a device called the Teach Pendant. The tool used to perform tasks by the robot is called the end effector, or end-of-arm tooling. This is attached to the manipulator. The location where the robot performs its task is called the robot cell. The robot cell contains the manipulator, tools needed to complete the task, and any products or materials that will be used for completion of the task. The robot cell is also a barrier that protects people from coming into contact with a moving manipulator or end effector. The Occupational Safety and Health Administration, or OSHA, is responsible for setting and enforcing standards for safe working conditions. OSHA recommends robots and robot systems meet the safety guidelines as established. Industrial robots are very different from R2-D2 and C-3PO from Star Wars fame. They are non-thinking machines that may be small, weighing only 50 pounds, up to giants over 5,000 pounds. They are capable of moving material over 1 ton. Robot safety begins in the design phase. Designers work to ensure that any hazards that can be eliminated are, and those that cannot be eliminated have safeguards in place to protect personnel and equipment. The work cell is the outer protective barrier. It is made up of walls and fencing to protect personnel from potential hazards. This area should be well marked, identifying safety measures needed. Only authorized personnel should be allowed to enter the work cell. Robots have many of the same hazards as other types of machinery. These include crushing or trapping, impact or collision, tripping, electrical shock, high-pressure hydraulic oil or compressed air, welding flash. Unique hazards to industrial robots include power systems, improper installation, environmental sources, mechanical failures, unauthorized access, control errors, and human errors. Personnel should be trained prior to operating or working around an industrial robot. Safe operation includes continued training as well as regular maintenance. Never become overly familiar with a robot and its normal motions. Personal protective equipment, or PPE, is required when working with any type of machinery. PPE required while working with a robot may include such things as safety glasses, hearing protection, hard hat, and safety footwear. This has been a brief overview of KanTRAIN, basic robotic parts, and basic robotic safety. We invite you to learn more about the robotic equipment at WATC provided by KanTRAIN.